Hey everyone. So now that we've learned in section 3.1 all the different names of angles and Hey everyone. So now that we have learned all the different names of the angle pairs in the last section, now we're going to learn about what happens when the lines that create those angles are parallel. So these relationships are only true when two parallel lines are cut by a transversal. If you just had two random lines like this with the transversal and you had your angles, these relationships are not true for something like that. These relationships, again, are only true when the lines are parallel. So the first one is called the corresponding angles postulate. And it basically says if two parallel lines are cut by a transversal, then each pair of corresponding angles is congruent. So when you have parallel lines, corresponding angles are equal. So for example, if I said the measure of angle 2 was, say, 80 degrees, then the measure of angle 6, which is corresponding to 2, would also be 80 degrees. That's the corresponding angles postulate. That's why angle 6 would be 80, because these parallel lines R and S are cut by the transversal, and 2 and 6 are corresponding angles. So that's the first one. Next is the alternate interior angles theorem. This one's called theorem. It's, again, two parallel lines cut by a transversal. Alternate interior angles are also congruent. So those are equal also. So if you take a look at angle 4, if I said angle 4 was, say, 100 degrees, then angle 5, which is alternate interior to angle 4, would also be 100 degrees because they're alternate interior angles, and based on the alternate interior angles theorem, they're congruent and the lines are parallel. Next is consecutive interior angles theorem. This one says if you have parallel lines cut by a transversal, consecutive interior angles are supplementary. They are not congruent. These add to 180, consecutive interior. So remember, consecutive interior angles are on the same side of the transversal, both on the inside. So like 3 and 5 would be consecutive interior. So if angle 3 was 80, angle 5 would be 100 because they add to 180. The next one is alternate exterior angles theorem. When the lines are parallel, alternate exterior angles are congruent. So that means of the 4 types of angles we learned last time, all of them are congruent except for consecutive interior angles. Those are supplementary. So if you look at the picture, if I said angle 1 was 100 degrees, angle 8, which is alternate exterior to angle 1, would also be 100 degrees because of the alternate exterior angles theorem. So those are the biggest theorems that we're going to use today. This next one comes up every now and then. It's the perpendicular transversal theorem. Remember that perpendicular means creates 90-degree angles. In a plane, so here's the theorem. In a plane, if a line is perpendicular to one of two parallel lines, then it is perpendicular to the other. And so I'll show you what this means on the picture. It'll make a little bit more sense. So let's say I had line L and line M, and let's say L was parallel to M. That's how you would write that. And let's say I had this line P here. If line P was perpendicular to L, and since L and M are parallel, which, by the way, I just realized I don't think I showed you in that last lesson, this is how you mark parallel lines. I think maybe I skipped over that. I don't know. To mark parallel lines in a picture, you have the same number of arrows. So I could have one set of arrows. I could have 2 sets of arrows. You'll see we're going to be doing something called angle puzzles where you may have a few sets of parallel lines. So you might have one set that has 1 arrow, one set that has 2. But a matching number of arrows means they're parallel. Anyway, so L and M are parallel. If P is perpendicular to L, it is also perpendicular to M. And if you think about why, perpendicular means there's a right angle, right? It's 90 degrees. Those are corresponding angles. So if that one's 90, so is this one. So it just means that P is also perpendicular to M. So that's perpendicular transversal theorem. Next, we're just going to do a couple examples. Let's start very simple. When you have parallel lines cut by a transversal, given one angle, say this one's 72, we can find all of the angles using the theorem. So I am going to justify all of these because on one of the angle puzzles that you're doing today, I want you to justify. So this is how you would justify each step. So say I wanted to find angle 3. 3 would also be 72 because it's vertical to angle 2. So this is what I mean by justify. 72 degrees, and then you would just say vertical. Whoops, I spelled that wrong. You would just say vertical, and then say to which one? To angle 2. These are not necessarily in order. Like based on what we have right now, we couldn't find 8 using a theorem. So I'll go to 6 next. Notice 2 and 6 are corresponding. So 6 would be 72. And I could say corresponding to angle 2. I could also say alternate interior to angle 3. That would work too. Now that I got 6, I could get 8. 8 is going to be 108 because it makes a linear pair with angle 6. So 108, and you would just say linear pair. And then you say with which angle? With angle 6. Then I could say, we could do 4 next. 4, there's a couple different things. 4 is a linear pair with 2 or 3. 4 is corresponding to 8. I'm going to use a different one, though. I'm going to use the relationship between 4 and 6, which is consecutive interior. So a lot of times you have many options for your justification. I'm going to abbreviate here. Consecutive interior to angle 6. Angle 5 would be 108, and you could either say vertical to 8, you could say linear pair with 6, you could say consecutive interior with 3. Alternate interior, I'll use that because I haven't used that yet. It's alternate interior with 4. So alternate interior with angle 4. And then angle 1 is 108. Oh, I don't know why I don't have a spot for 7. I'll add that in. Angle 1 is 108, and you could say so many different things. I'm going to say 108 because it's alternate exterior. I like to mix it up with my justifications because really you could say vertical or linear pair for so many of them. Alternate exterior with angle 8. So there's just a really simple, like how you would find angles and justify. The one you're going to do today is much more complicated than that. I mean, not too crazy, but a few more transversals involved. So real quick, I'm not going to fill in all the blanks over here just to save time. You can if you'd like, but I don't want this to be like a half-hour video. So basically something like this. This is what I meant with the arrows. So see how C and D have 2 sets of arrows. That means those are parallel. And then A and B have 1 set. So that means those are parallel. So when you know that lines are parallel, the theorems that we just learned will work for any transversal that goes through those lines. So we were given that 3 is 43. And then we're asked to find the rest of them. So basically you can use the relationships like since both pairs of lines are parallel, that means that basically all these angles are either going to be 43 or 137 because they're supplementary. So like 5 is vertical to 43. I mean vertical to 3. Then you could do like 13 is corresponding to 5. You could do 11 is vertical to 13. Then we could go to 15. 15 is alternate interior to 11. 9 is vertical to 15. 1 is corresponding to 9. 7 is vertical. So all of those are 43 and all the rest will be 137. So 4 is 137 because that's a linear pair with 3. And then you could do like, 6 is vertical to 4. 12 is alternate interior to 6. 14 is vertical to 12. 16 is corresponding to 14. 8 is corresponding to 16. Whoops, I don't know why I put a 6 because I said 16. 2 is vertical to 8. So that's how you would fill them in. Again, that's pretty easy. The one that you're going to do for practice today has a little bit more involved. It has parallel lines and then like a couple different transversals. So you would just have to remember that the theorems and everything work along each transversal, along that transversal. So in every single picture that you're going to do, it's not necessarily like this where all the angles are pretty much the same. Oh, I just noticed I put a 136 for another one of them. I think because it was angle 6. Whoops. Okay, so that's that example. We're going to be doing a few different angle puzzles. We'll probably do some in. Okay, now for some algebra problems. So something like this, you always want to label the picture. So it says the measure of angle 1 is 3x plus 40. So that's this one here, 3x plus 40. And then measure of angle 3, that's this one here, is 2x plus 70. So before we set something up, we have to ask ourselves, what kind of angles are they? They're on the same side of this transversal, one inside, one outside. So those would be corresponding. And we just learned that when the lines are parallel, corresponding angles are congruent. So you're just going to do 3x plus 10 equals, oh, not 10, just kidding, 40 equals 2x plus 70. And then solve for x. So subtract 2x from both sides, subtract 40 from both sides, and you end up with x equals 30. If it asked us to find the measures of the angles, you'd have to take 30 and plug it in here into here to get the measures of the angles. So there's the first one variable. Number 4 is one where we have 2 variables, but it doesn't matter which one you find first. So here, I'll show you. So we have that these 3 lines are parallel, 1, 2, 3, and we have this transversal. So even if you have more than 2 parallel lines, all of those theorems that we learned at the beginning will still work. So like, see how 56 is corresponding to this? So that's also 56. The reason why I wrote that in is right now, without that 56, there are no angles that have any relationships of the ones that were given. So sometimes you have to fill in more angles than are given. And so now notice that these two are a linear pair, which hopefully we know now means that they add to 180. So for x, you can do 4x plus 56 equals 180. Subtract 56 from both sides. 4x equals 124. Divide by 4. X equals 31. So there's x. And then to get y, notice that, well, we could do a couple different things. This one right here is 56. Okay, so 3y minus 11 equals 124. Add 11 to both sides, we get 3y equals 135. And now if we do 135 divided by 3, we get 45. So there's example 4. It has an x and a y, but you can find them independently. Like you can find x by itself, y by itself. You don't need one of them to find the other. That's what example 5 is like. So our last example, if we label the picture, angle 5 is 2x minus 10. Angle 7 is x plus 15. Draw a little line over here. Angle 6 is 4, and then y minus 25. So this one, we have 3 angles that were given. Notice 2 of them, 5 and 7, have an x in them. And then this one over here has a y in it. So basically what you want to do is you want to look at the ones that both have an x, which is 5 and 7, and ask yourself, what kind of angles are they? These are on the same side of the transversal. This is the transversal. One inside, one outside. Those are corresponding angles. And as we did in the first one, corresponding angles are equal. So 2x minus 10 equals x plus 15. Solve for x, subtract x. So it's going to be x minus 10 equals 15. Add 10 to both sides. X equals 25. Now that I found x is 25, I have to use that to help me find y. On your test, a lot of you just, there was one that had an x and a y in it. So a lot of you were able to find the first one, but then it seemed a little bit lost on how to find the second one. So what we're going to do now is we're going to plug in x equals 25. Because notice that angle 6 and angle 5, those are alternate exterior angles, which means they're equal. I just made a mess of this, so I'm going to erase this for a second. So angle 5 and angle 6 are equal because they're alternate exterior. So if I can find the measure of angle 5, that will be the measure of angle 6 as well. And then we can just set up an equation. So angle 5 is 2x minus 10. So you're going to do 2 times 25 minus 10. 2 times 25 is 50 minus 10 is 40. So this one's 40, this one's 40, and more importantly, this one's 40. So the last thing I can do is I can use the 40 and the 4 times y minus 25 and set up an equation. So I can do 4 and then y minus 25, and then it's equal to 40. I just found that angle 6 was equal to 40. Now to solve this, you could distribute or you could get rid of 4. I feel like a lot of you would probably distribute, so that's what I'll do. Add 100 to both sides. So then we have 4y equals 140. And so divide by 4, y is 35. So there's your second example. A lot of the ones on the practice today are like this problem. So you find x, plug it in, and then set up your other equation based on what you got for x. So we will do some more tomorrow. Please let me know if you have any questions. Have a good day.